All right, the last video we finished up with this problem where you had to find the probability of selecting a green marble and then probability of selecting a black marble. I'm going to do one more example out of this problem just to kind of show you how probability can work. All right, what if I say I want to know the probability of selecting an orange marble? All right, what we're going to do is we're going to first of all figure out how many total marbles we have. We have 10, so our bottom number is going to be 10. And how many orange ones do we have? You look up here, you have red, you have green, you have blue, and you have black. We don't have any orange, so our probability of selecting orange would be 0 out of 10, which represents 0%. So sometimes you're going to have a 0%, sometimes you would have 100%. 100% would be an example like this. What is the probability of selecting a marble? Well, you have 10 marbles. Probability of selecting a marble would be 10 out of 10 because everything in there is a marble. So that would be 100%. All right, so what we're going to do with this video, this third video, is get into the specific kinds of probability. You have two types of probability that we're going to focus on this year. We have what's called theoretical probability, and we have what is called experimental probability. So if you will label your paper theoretical and experimental probability. All right. We've talked about outcomes. Outcomes are the results of an event. That event could be flipping a coin. It could be selecting a card out of a deck of cards. It could be rolling a dice. A simple event, as we talked about, is where you have one outcome. Then this new phrase or new word is called a sample space. A sample space is a set of all possible outcomes. So if I was to flip a coin, let's say a penny, a quarter, whatever, it could land on, well, the board's going to work. Let me turn it off and turn it right back on real quick. All right, so you have a coin. You have two options that a coin can land on. All right, it could land on tails. It could land on heads. When we flip that coin, we're going to get one outcome, tails or head. That means it's a simple event. The outcomes are the two options, tails or heads. The sample space is a set of all possible outcomes. So in this case, all possible outcomes are tails or heads. All right? So as we move on, we're going to first of all talk about theoretical probability. Now, if I ask you, what are my two options when flipping a coin? You have heads and you have tails. If I was to specifically say, okay, what is the probability of it landing on heads? Most people are going to say 50%. What is my probability of landing on tails? Most people are going to say 50% because there's only two options and it's going to land on one of those two. So you have a 50-50 chance of it landing on one or the other. Now, the next thing, let me go ahead and highlight this so that you have it. You need to know what theoretical probability is. Now, let me go back to theoretical probability real quick. I just asked you about a coin. Now, that refers to what should occur. Now, does that mean we're always going to have a 50-50 chance? Does that mean half the time, if I flip a coin 100 times, does that mean it's going to land on tails 50 times and heads on 50 times? No, it's just what should occur during that experiment. I could flip a coin 100 times, and out of those 100 times, it could land on tails 90 times, and then heads only 10 times. Then you have what is called experimental probability. Experimental probability is what actually occurs when you repeat the experiment many times. So let's say I flip a coin 100 times, and I record my outcomes. I may record that it landed on tails 40 times, and it landed on heads 60 times. Now, is that 50%? No. It's what actually occurred. It's what actually took place. So with experimental probability, that is when you actually do the experiment. Theoretical is what should occur without doing the experiment. So I'm going to put a little note here. Without doing the experiment. And experimental probability is what actually happens when you do the experiment. All right? So as you're going through these, please ask questions because some people think this can get tricky. All right? Let's move on to the next thing. When we find theoretical probability, now we're going to focus on theoretical probability as far as what we have to do. To find theoretical probability, we're going to use the formula. It's the number of ways the event can occur over the total number of possible outcomes. Okay? So example 1. Find the probability of rolling a number greater than 2 on a number cube. Alright, first little hint here is there are 4 ways this can occur. So let's think about a number cube. So if you have a dice or a die, whichever way you want to say it, look something like that. You have 6 sides. Each side has a number on it. 1, 2, 3, 4, 5, and 6. So those are the 6 possibilities of rolling a die and what you can get. Now we want to know the probability of rolling a number greater than 2. So I'm going to say the probability greater than 2. Alright? So if I look at my outcomes that I can possibly get, 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, and 6 is greater than 2. So we're going to use this formula right here. It's the number of ways the event can occur over the total number of possible outcomes. So when I roll a dice or a die, I have a total of 6 possible outcomes. What I'm trying to get is the number that's greater than 2. So I have 1, 2, 3, 4. 4 ways to get a number greater than 2. So my probability is 4, 6, which we would simplify, divide each of those by a common factor. 2 is a common factor, so if I divide each of those by 2, I get 2/3. So right now we're just going to focus on the fractional answers. Alright, so my probability of a number greater than 2 would be 2/3. Okay, it's the number of ways the event can occur over the total number of possible outcomes. So, as it has right here, this is basically the same thing as what I just did. So you don't need to recopy that. But if you will, copy this down, please. So this is the probability of selecting or rolling a dice and it landing on a number greater than 2. So, let's move on. Alright, I want to insert a blank page here. So we have theoretical probability. Another way of writing the formula is what you want over the total. Okay? So if you can think about this, that's an easy one to remember as opposed to the other one. So theoretical probability is what you want over the total. So I'm going to give you another example. So let's say we're rolling a dice, and I want to know the probability of rolling the dice and getting a number less. Let me do it a different way. Use a coin. Now let's go ahead and let's just say probability of rolling a dice and getting a number less than 6. Alright, so if you think about a dice, you have 6 options. 1, 2, 3, 4, 5, and 6. A number less than 6 would be 1, 2, 3, 4, and 5. Alright, so how many is that? What we want. What do we want? We want a number less than 6. There are 1, 2, 3, 4, 5. The total number is 6. So our probability is 5, 6. Alright. Now we're going to move to what's called experimental probability. Alright, the next thing we're going to talk about is experimental probability. With experimental probability, it's the number of times the event occurs over the total number of trials. So our example that we're going to use, it says, during skating practice, Sasha landed 8 out of the 12 jumps. What is the experimental probability that she will land her next jump? So when you want to find the probability of something that's going to take place next, you have to refer back to what has already happened. So what has already happened is she landed 8 out of 12. So the number of times that event occurred is 8 times. She landed it 8 times. Out of the total possible trials or jumps that she took, 12. So my probability of her for landing the jump would be 8 over 12. And 8 over 12 is going to simplify, divide each of those by 4, and you get 2/3 for that one as well. So the probability of landing the jump is 2/3. Okay? So, another way of writing experimental probability is what you want over the total. So what we want is what she's trying to do, land it. She landed it 8 times. The total is 12, so it's 8 out of 12. So our probability of landing the jump is 8 out of 12. Now let's kind of turn this around. I'm going to give you another example based on this scenario. But first, if you will, go ahead and copy this down. All right, our next scenario is, what is her probability of not landing it? All right, we'll have to think about it. She landed it 8 times, so how many times did she not land it? Okay, she landed 8. She tried a total of 12, so if I subtract, that means there were 4 that were not landed. All right, so what do we want? Our top number represents what we want. We want it to be how many that she did not land. So she did not land 4 out of her total of 12. So her probability of not landing something is 4/12. And if I simplify that, divide each by 4, that gives me 1/3. So my probability of her probability of not landing the jump on the next one would be 1/3. So you can use what you have to figure out one thing, and then kind of turn it around to figure out the other part of it. All right, so let's try this. While bowling, Alexis rolls a strike in 4 out of the 10 frames. What is the experimental probability? Remember, it's what you want over the total. All right, what we want is her experimental probability of rolling a strike. So what did she get? She got 4 strikes. That's what she wanted. So it's 4 out of the total, 10. So her probability is 4/10. So let's just simplify it, which gives you 2/5 or 2/5, because 2/5 is what you get when you divide 4 into 10 by 2. So her experimental probability of rolling a strike would be 2/5. Okay. What would be her probability of not rolling a strike? So what I'm going to do is I'm going to put a line through it. Okay, she bowled 10 frames, so her total is 10. 4 of those were strikes, so if 4 were strikes, that means 6 were not strikes. So her probability of not rolling a strike would be 6 out of 10, which when simplified gives you 3/5. So this is the probability of strikes. And right here on the other side, probability of not rolling a strike. So if you will copy down this information and go ahead and copy this problem down right here. Now, what I want you to do is I want you to work on the rest of these problems, numbers 2 and 3. And there's another one down here at the bottom. So once you do these, I'm going to have you scroll down and work the third one. So the next one is down here at the bottom. As you'll notice, number 2, it says theoretical probability. Number 3 is the experimental probability. And the last one says experimental probability. Now, as you're working on these, let me know if you have any questions whatsoever, and I'll be glad to help you. All right, just something I kind of want you to be aware of. And if you'll go ahead and copy this down, this may come in handy as you're working some problems that deal with a deck of cards, because you may see a lot of questions about cards. All right, you know with a deck of cards that you have, let me get this back, 52 cards. Okay, this is just some general knowledge. You have a deck of cards that's broken up into what are called 4 suits. The 4 suits are clubs, spades, hearts, and diamonds. Each suit has these cards right here. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King.